in my another vector geometry tutorial. It's from exercise 13.3, question number 2. We are drilling. Information provided, and there is a diagram given on the right side as well. AB equals to 5A. On the bottom line it is written AB equals to 5A. In this diagram I am saying, and DC equals to 3A. We needed to know actually what the parts are given there by reading the question first. And CB provided B, so 3 lines are given on the outer side, and AX lambda SC1 constant and dx equals to mu dB. This is the another constant. The first question, find in terms of A and B. This is the first question. AB, first one is the AD. So let me see what is the AD. A1 we are doing AD. So AD, actually one line is here A, another point is D. We cannot go directly. Let me go from A to B first, then B to C. We can go like this. In this direction we can move. BC, then CD. So AD you can write AB. Let me write the vector accordingly. AB plus BC plus CD. So vectors are given AB in that direction, so you would the 5A, and BC is vector given the opposite direction, that's why we needed to use minus B, and vector DC given, but we are moving from C to D, we also needed to use a minus sign 3A. Let we add them, 5A minus A, which is 2A minus B, and that would be the answer of the first part, AD. Next, move to the second one, which is DB is written, and see the diagram again. I'm going to erase the previous one because okay, moves to the second part. It is written there DB. From D, if we want to go to the B, see the diagram. From D we can easily go, so from here we are moving till to B. So DB we can write DC plus CB. It's very simple and easy question. Directly can go DC, we can write 3A because according to that direction given, and CB also B, so we can write directly B, and this is our answer of the A2 question. Done. Let me use different color to do the other questions. Now I move to the question number B, and it is written there, find in terms of lambda and mu A and or B AX first. So let me see the AX. One information is provided which is lambda AC. So let me write here AX, so you can write directly lambda AC. So let me write AC according to the way we did AC. We can move from here to there, AB plus BC. So let me write AB. We are not writing in terms of position vector right now because there is the position vector is given, OB plus BC, and it's easy to write lambda into AB part is given in that direction 5A, but BC part is not provided according to the BC direction, it is given CB direction. That's why we needed to write here minus B, because we are going to the opposite of the vector given. That is the first part of this question B1. Now let me move to the part 2. From here it is written here dx. This question we are going dx, and dx provided here mu dB. Let me write mu dB. Now see the vector. What is the dB position? dB, we already have the vector dB, we got the answer of dB. This is 3A plus B. We are going to use that one, 3A plus B, and this is our answer of that part. Now we are moves to the last one, which is the C, and it is written there, find the value of lambda and of the value of mu. Let me use the different color now to that question. So we needed to form a vector equation to do that question. Especially it is written, we have AX, we already have dx. So we can relate with the AD. We have the AD. Can you write to do the question number C? AD equals to, which you can write AX plus AD equals to AX plus XD. Yeah, we can write that. So AD, we already have the vector of AD, which we got 2a minus b. Let me write 2a minus b equals to AX. We already have the vector, which is this. Let me write lambda 5a minus b and plus xd, but it is we got the value dx. We just needed to apply minus sign in front of it to make it the xd. So let me write xd extremely sorry, minus mu into 3a plus b. This is the value of xd because we got it as a dx. Dx is here. Now we can say it's a vector equation. Vector equation, there is a property of the vector equation. By equating the coefficient from the both side, we can find out the lambda and mu. Let me write in terms of lambda and mu first. So if we take from there a common, then we can write 5 lambda minus 3 mu. This is the first part of the coefficient of a. Then we also can write it by taking b common, plus if we take b common, then the part remaining minus lambda, then another part if we take b common minus mu, we can write from there. Now equate the coefficient of a. If we take the coefficient of a, coefficient, it's very important, coefficient of a, or we also can write terms with a because it's a vector equation. If from the vector equation, that unit vectors or the individual vectors are equal always. So equating the coefficient of a, we can write from the left side we got 2 here, from here we got the value, and from the right side it is 5 lambda minus 3 mu. Let me write 5 lambda minus 3 mu. So we can write itself equation number 1. Then if we equate the coefficient of b, then it should be minus 1. From the left side we got, because only the minus 1 remaining, and the right side it is minus lambda minus mu, second equation. So just we needed to solve that two equation, that's it. From the second equation we can write, if we remove the minus sign, which is 1 equals to lambda plus mu. I multiplied with the minus on the both side. Now we are going to solve that equation. This is second equation. We can multiply with the 3 whole equation, then it turns to 3 equals to 3 lambda. If we multiply the 3 equals to 3 lambda plus 3 mu. Now put the first equation below of the second equation. I mean 2 equals to, you can write 5 lambda, and it is written 3 lambda. I took it from here, from the left side. Now add these two equations together. We can cut out this 3 mu, and on the left side it gives us 3 plus 5, 3 plus 2 is 5, and right side it is 3 plus 5 is 8 lambda. So easily from there we can write lambda equals to 5 over 8, and this is our answer of the lambda value. Now let me put this value here to get our mu. 5 by 8 we can write plus mu equals to 1, so mu we can write directly 1 minus 5 by 8, which gives us 3 by 8, and that is our value of mu from here. Hope guys the way we did the question you understood from here. This is from exercise 13.3, and the questions I'm showing you Cambridge IGCSE and O-level additional maths book. This is completely Cambridge book. Rest of the question from this exercise 13.3 almost similar type. So if you at least do 4 or 5 questions from here, you are able to do rest of the questions from that exercise. Thanks for watching with patience.